The West Coast mountains are also building up. Okay. During the late Paleozoic, the Cordilleran belt was almost as lively as that of the Appalachian Mountains, or the creation of the Appalachian Mountains. Right? So remember, before the Cordilleran Mountains were built, a passive margin existed on the west coast of the North American Craton. And so it was a very quiet environment. Then as this passive margin turned into an active margin and the Pacific plate started colliding with the North American plate, the second orogeny to happen was the antler orogeny. And during the antler orogeny, volcanic island art converged and started forming on North America. Now, during this time, when the antler mountains were being pushed up and formed, notice that a shallow sea developed on either side of the antler mountains. So as the antler mountains were pushed up, the area besides them bent down. So shallow seas existed to the west and to the east of the antler mountains. What evidence do you might think we could use to know that these shallow seas existed, right? How do we know? What evidence would we look for in the rock record? Well, what we see is evidence of marine facies, right? Marine rocks, such as limestone. If you've ever gone to the Grand Canyon or seen pictures of the Grand Canyon, you might have known that the rim of the Grand Canyon is this vibrant white rock. And we call that the Kaibab limestone. And that was created during the antler orogeny when a shallow epicontinental sea surrounded the antler mountains.